Hello everybody, in this video we will discuss SN2 reactions of alcohol with thionyl chloride. Well, the product is gonna be the same like before we did with the zinc chloride and HCl or HBr, where you will be replacing an OH with chlorine or halogen for that matter. So let's look at how the mechanism works. So quick recap, SN2 means substitutions, N stands for nucleophilic, and 2 is bimolecular reactions. So you will notice that in our rate determining step, we will have 2 units are involved. Okay, so let's start with the mechanism. So you have an alcohol, and we got our thionyl chloride. So thionyl chloride is SOCl2. So what this will do is sulfur is slightly delta positive. So sulfur is an electrophile because it is connected to a bunch of electronegative atoms. So oxygen has extra electron and sulfur is electron deficient. So it will come and attack the sulfur. Now, as a result, it will push the pi electron that existed between sulfur and oxygen towards the oxygen side. Okay, so now let's draw the next intermediate. You should pause the video and try to predict how my next intermediate will look like based on the arrow. This is a good habit, good practice. Okay, so let's say I'm gonna put this O minus and Cl. Okay, so let me draw all the electrons. So that's our O negative ions right there. So this here, now sulfur becomes actually a tetrahedral intermediate right here because it has 4 bonds. Tetrahedral intermediate with a negative charge on top is actually not very stable. So oxygen is not very happy in this state. It wants to go back to its glory date by bringing back the pi bond. Okay, so what it will do is it will bring back the pi bond, but sulfur will simultaneously kick out a chlorine group. And another thing I forgot to mention here is the oxygen. It should have a positive charge because oxygen now have 3 bonds. It has give extra electrons. So shortcuts, every time oxygen has 3 bonds, it should have a positive charge. Every time oxygen has 2 bonds, like here, it should be neutral. Every time oxygen has 1 bond, like here, it should have a negative charge. So again, 1 bond negative, 2 bond neutral, 3 bond positive. That's a easy shortcut. Okay, let's look at here what's happening. So we got OH, S, O, and I will write down the chlorine like this. Okay, so the pi electron is back in the menu. The pi electron is back in the menu. All right, so let's put the positive charge. Okay, so every time we create a positive charge on oxygen, you should try to look for to neutralize it somehow. So our reaction contains an ingredient because we are doing this reaction in the medium of pyridine. Pyridine is kind of a benzene ring, but 1 carbon atom is displaced by nitrogen. So it is a heterocyclic benzene ring, that's if you want to say that way, but still it is an aromatic compound and it has lone pair here, and this lone pair will act as a proton abstractors, right? So it will abstract the proton from our intermediate. Okay, so now we will have a situations that is gonna look something like this, and our pyridine is gonna be positive charge. So this is our pyridinium ion, we call it. Okay, so we have removed a Cl minus. So don't forget that Cl minus existed. So let's bring that Cl minus to actions. So we got our Cl minus right here. Let's show all the electrons. Okay, so now what would happen is this Cl minus would able to attack the carbon atom right here. There are two carbon atoms, right? Now, why this would be able to attack? Well, this would be able to attack because the O bond between carbon and oxygens, it is now a decent leaving group. It can go back to produce sulfur dioxide, and simultaneously the electron deficiency will be maintained by attack of chlorines, right? Not electron deficiency, the octet will be maintained by the attack of chlorine. So you noticed how many units involved in this step. So you have chlorine minus is attacking, and there is another molecule, and this molecule is breaking. So you have 2 units, 1 and 2 units. That's why this step is is called bimolecular reactions. And it turns out this is the step where that determines the rate of the reaction. So this is why it's called SN2 reactions. Okay. So based on this, you're gonna have chlorine, and you're gonna have sulfur dioxide, and then you're gonna have Cl minus, because the Cl minus is going out there as well. Okay, and the Cl minus will be counterbalanced by the positive charge of pyridinium, or it can do the next set of reactions where it will attack. Okay, so this type of reactions is the SN2 reactions of SOCl2. This type of reaction happens only in primary, which is best, or secondary. So in tertiary alcohol, you cannot do this reactions because of the steric hindrance. So tertiary alcohols for SN2 reactions, I should say with SOCl2. With SOCl2, it's only going to happen primary. This is the best. This is okay. Tertiary won't happen. So let's try to do stereochemistry of SN2 reactions. So stereochemistry of SN2 reaction. So this is going to be very good for your exam preparations, MCAT or DAT or our exams. Okay, so let's say we have something like this. A, we got leaving group, and then we got 2 groups. B is pointing up and C is pointing down. So this is going to be a quick recap. So if you know the one where we shown the bond by straight line, so these two are the plane of the screen that you're watching. So if you're watching this on iPad, this A and the leaving group, they are both in the plane. However, B is out of the plane. B is coming out towards you. C is going behind your screen. Okay, so that's how it looks like. Okay, so what happened is we got nucleophile. So nucleophile has negative charge. Now this nucleophile can approach on the opposite side. So what is the opposite side of leaving group? Leaving group is to the right side. Opposite of right side is going to be left. So leaving group can approach only from the left side. It cannot come from the right side for the structures. So it has to from the opposite side. So leaving group is attacking from the back. So this is SN2 attack. Opposite of the leaving group. Okay, so if the leaving group was up, then you should approach from the bottom. If the leaving group was from the bottom, if the leaving group is towards the bottom, then you approach from the top. So always opposite. So I draw this on plane because then it will be easier for us to explain. So let's look at the transition state. So how does the transition state actually looks like? So let's draw this. So we got A as it is, and the B, it's gonna go through a flipped state, right? So the whole structure gonna get flipped, and you notice B is there, C is there. So they are all A, B, C are in a plane. I don't know how to draw this, but what's going to happen is slowly the entire structure will get flipped. It will make a lot more sense in a second once I draw the final product. So you can see the leaving group, the bond is partially being broken. So this leaving group is partially broken bond. So which means the leaving group is running away with the electron. So now it has a delta negative charge. And the carbon atom is creating a delta positive charge. And then the nucleophile, which is coming from the opposite side. So the bond is being partially being made. So again, nucleophile becomes negative to delta negative. So this is the partially being, so this one is partially made bond. So it hasn't been entirely. So this is how the transition state look like for an SN2 reactions. Okay, so transition state, this is how it's gonna look like. Eventually what would happen when leaving group entirely goes away, so you will have A and B has flipped. B and C has flipped, like instead of pointing, well, not exactly flipped, we should not call it flipped, but it's easier to visualize if I draw the nucleophile. So you noticed our leaving group was pointing to the right, but now the incoming group is attached to the left. So the stereochemistry get inverted. So stereochemistry get okay, the reason I draw this way to show you that the leaving group has gone away from the right side and nucleophile has come from the left. Some people and a lot of books also try to write like this, which is also correct, is you put the A as it is. So you notice A was here on the top, but you put the nucleophile on the same side of the leaving group, but now instead of, okay, so now you put the B towards the back and C towards the front. So you notice B was before to the top, now it's to the bottom. C was before at the bottom, now it's to the top. So this is also stereochemistry inverted. So when you switch one of the group while drawing the structures, that's called inversions. But if you switch two of them, then that's inversion. So don't switch B and C and also simultaneously nucleophile. Like both of these are correct, but don't switch, like don't draw it like this. So this is incorrect. So B, okay, not there. Okay, I'm gonna draw the nucleophile first. Okay. Okay, so this is the same as this one, right? But if you replace it, B and C, where what you do is you replace the B from the top to the bottom and C from bottom to the top, and also you flipped nucleophile as well, then this is the wrong structure. So this is wrong. Okay. Okay, so in the next video, we will talk about the reaction of PCl3 and some more problems. So maybe you can try this problem. So let's say you have a OH, and then you react with SOCl2 pyridine. You will see a lot of questions like this. So what would happen? Well, what is the nucleophile in our case? Our nucleophile is chlorine, right? Chlorine minus. So this has to have approach from the opposite side. So OH was to the top. So OH was to the top. So which means which side it should approach? The chlorine should approach. Chlorine should approach from bottom. Okay, so the new group has to be from the bottom. So it has to come from the bottom. There we go. So that's how you can quickly draw the products. Let's do one more problems. Okay, so we got like this, OH, and let's say you want to do SOCl2 pyridine. So in this case, the OH group is to the top. So chlorine has to approach. I'm not drawing the entire mechanism. I'm just showing one of the intermediate. Okay, so chlorine has to approach from which direction? So Cl minus has to approach SN2 attack from bottom or top? Obviously from bottom. So the product that you'll be making is gonna be, so nothing changes on this carbon atom, okay? But your chlorine is gonna be from here. All right. Okay, in the next video we will talk about the reactions of alcohol with the PCl3 and PBr3. Stay tuned.